Hi, this is Tim, and welcome to what is probably going to be the most unpopular video of this series, at least if it goes like our RS Logix 500 series went. But it is very important that you understand this video. It has to do with duplicate destructive bits, or duplicate OTEs mainly. And two things are said about them. One, a lot of people say that it's illegal to put two OTEs addressing the same output in a program. And another group says if you do this, it's okay because the last rung will win. So we're gonna put two rungs into a program to disprove this because the last rung does not win. The PLC is going to execute code in a methodical order and it will always come out with a predictable outcome based off of all the rungs. Please take a moment to subscribe to our channel. We put out at least one automation video a week and we hope you like it. So hit that like button, or really if you just really disagree with me on this one, go and hit that dislike button. It's fine. For this video, we are going to be using our Micro 820 PLC trainer. So we're going to start with the first rung that we ever programmed, and we're going to use switch 1. So we're going to make switch 1 turn on the green light. So let's go ahead and create a new program, and we'll just call this last rung. And we're going to select controller, Micro 820, the 2080 LC20 20 QWB. Select it, add to project, and let's go ahead and set up our Ethernet configuration. It's going to be 192.168.110 with a subnet at 255.255.255.0. And let's right click programs, add ladder diagram. And let's open up that. And we're going to use the direct contact examine if closed. We're going to look at switch 1, which is tied to input 8. So let's go ahead and label that as switch 1. And then we're going to use a direct call. And we are going to address output 0, which is our green light. And let's go ahead and download this program. Now, if you need help downloading your program or installing Connected Components Workbench software, I'll put a link to a playlist in the description that goes through how to install the software, how to configure communications, upload, download, bit instructions, timers, counters, the whole works. Now, we've been step by step through how these two instructions work many times, and I'm gonna skip to the end to do that, just because, one, I don't want to bore you too much, but also I almost want to catch you off guard here. But this basic instruction, switch 1 turns on the green light. That's all there is to it. Now let's say our customer or our machine operator says, well, I don't really like the switch. I'd rather have a start-stop configuration. Or let's say that he says, hey, I want to add a second output. Whichever way you want to work this scenario. Let's go offline and let's add that. So now let's add a second rung to this. So we're going to grab another rung and we're going to use the direct contact, examine if closed. And this time we're going to look at input 4, which is our green button. Now, if you're wondering how I'm coming up with these wire numbers, look at our wiring enough to get a started exercise in the playlist, because that's where they're coming from. But we're going to look at the green button. And also, while we're here, we're going to need input 6, which is our red button. So we'll select our green button, then let's use the direct call output energize, and we're going to do the green light. Now, either we were changing the program so the green light functioned differently, or I accidentally put in. It doesn't matter. Mainly, we ended up with this duplicate output instruction. So now this is still a start stop. So we're going to add our branch instruction and we're going to seal it in with our green light. Green light. And then we're going to use our red button to stop it. And if you're not sure how this works, like I said, we have a video on both of these instructions down in the playlist. But now we're going to download this program. And first, prove that no, this is not illegal. Because if a program will download, then it's not illegal. Now, while we're downloading this, in our RS5000 lesson series, I put out a questionnaire many years ago about this particular exercise. And I asked the questions, first, which rung is going to control the green light? And I've always been surprised because it's been consistent over the years. It's dead split, 50-50. Half the people think rung 1 is going to control it. Half the people think rung 2 is going to control it. And then I asked the following questions, and really think about these questions before you continue with this exercise. What will happen when switch 1 is turned to the right? Will the green light be on or will it be off? What will happen when switch 1 is turned to the left? What will happen when the green button is pressed? What will happen when the green button is released? And finally, what will happen when the red button is pressed when switch 1 is on? So first, what will happen when switch 1 is turned on? Well, if you are a believer in the last rung wins, then you're probably going to say nothing. So we switch 1 on, and our green light turns on. So now what will happen when switch 1 is turned off? Well, first, we got a really strong seal in right here. The green light is absolutely on now. So there's nothing that could actually turn this rung off. So let's switch 1 off, and the green light goes out. So now it looks like, no doubt, rung 1 wins. It is not the last rung. So the next question in our exercise is, what happens when the green light is pressed? The green light comes on. A lot of people say, well, okay. This time, rung 2 definitely got the green light on, so it will keep it on. So when we let off of the green, it'll definitely stay on now. So let's let off the green button, and the green light goes out. And there was one final thing before we really start walking through these rungs, is what happens if switch 1 is on and we press the red light. It looks like the rung 1 definitely has a stronger preference over this light. So let's press the red button, and the green light goes out. Light off of it, it's going to come back on. So how is this working? First, let's go back and let's start working through this step by step. Let's rearrange these a little bit more, just so we don't have to do any scrolling. Okay, now we can see all of it. So let's go through it step by step and see if we can understand what's going on here. So right now, switch 1 is off, neither button is pressed. Our direct contact is going to say, go look for 1. Where? At input 8. Do I have 1? No. So it's going to pass false conditions on to this direct coil. And a false direct coil goes and writes a 0. Where to? To output 0, which is our green light. Now it's not writing to this actual light right here. Remember that. It's only writing to this global variable right now. It doesn't write to the actual light until the end of the program. So next it's going to go to rung 2. It's going to look at this direct contact and say, go look for a 1. Where? At input 4. Do I have 1? No. So it's going to be false. It's going to get to this branch. It's going to go back. It's going to look at this in direct contact and say, go look for a 1. Where? At output 0. Do I have 1? No. So it's going to be false. So since no continuous paths were true around these branches, it's going to go on with false conditions, and it's going to go to this reverse contact. Say, go look for a 0. Where? At input 6. Do I have 1? Yes. So this will be true, which is represented by the red here, but we don't have a continuous paths of trues all the way across. So this direct coil is going to be false. It's going to go right a 0. Where to? To output 0. Then it's going to update its outputs based off the global variables, physically turn this light off, and do it all over again. Super fast, 1,000 times or so a second. But now let's switch 1. That's a lot of switches. Switch 1 on. And before we do though, when you're really studying this, you look at this second rung and say, the green button is not pressed, our green light is not on, so there's no way that this can be true. But let's go through it step by step. So let's switch one on, and the green light does come on. This instruction is going to say, go look for a 1. Where at input 8? Do I have one? Yes, so it's going to be true. It's going to pass true conditions on to this direct coil. And it's going to say, go write a 1. Where to output 0, which is the global variable associated with this green light. But this is not the green light. And that's very important to make sure you're understanding during this exercise. So for this split moment in the execution of this program, the global variable is true, or is a 1. But this light is still off. Then it's going to go to this next rung, and this one's going to say, go look for a 1. Where at input 4? Do I have one? No. So it's going to be false. Gets to this part of the branch, it's going to go to the next level, and then it's going to get to this direct contact, says, go look for a 1. Where at output 0? Now again, this is the global variable output 0, not the physical light, because right now, the output itself is off, but we just wrote a 1 to this global variable for output 0 with rung 1. And that's where it's going to go look. So it looks there, it sees a 1. So this is going to be true, this lower branch. And since we have a continuous path between one of our branches, it's going to continue on true to our reverse contact, which is going to say, go look for a 0. Where? At input 6. Do I have one? Yes, so it's going to be true. So we have a continuous path of trues from left to right. And that is going to make this direct coil true. And a true direct coil is going to go right a 1. Where? To the green light. Then it's going to update its outputs, which turns on the physical output, which turns on the light, and it starts over. So next, when you're studying this, it sure does look like there's no way for this green light to go out, because the green light is on. We're not pressing the red button, so the green light should stay on when we switch 1 off. But when we switch 1 off, it went out. And let's walk through that. This is actually going to be exactly the same as the first time we walked through, but it's worth doing it again. This instruction is going to go look for a 1. Where at input 8? Do I have one? No. So this is going to be false. And it's going to pass false conditions on to our direct coil. And a false direct coil is going to go right a 0. Where to? Output 0, which is the global variable associated with the green light. Now, here's the difference between it and the first time we went through, is for this microsecond of the program, this green light is now physically on, but our global variable that controls it at the end of the program is off. It is a 0. It's going to go to the next rung, and this is going to go look for a 1. Where at input 4? Do I have one? No. So it's going to be false. It's going to go down to the next layer of the branch, and this is going to go look for a 1. Where at output 0? The global variable, because remember, this light is on still, but this global variable is off. So this is going to be false. So it's going to pass false conditions on to the reverse contact, which goes and looks for a 0. Where at input 6? Do I have a 0? Yes. So this will be true, which is represented again by the red. But since we don't have a continuous path of trues, then we are going to be false over to the direct coil. And a false direct coil goes and writes a 0. Where? To output 0, which is, again, the global variable associated with the green light. Now here is the really important thing to understand. It may seem like a small detail, but right now, at that very small microsecond of the program, this is writing a 0 to that output global variable, and that light is still on. Then we finish our program, and it's going to update its physical outputs based off the global variables, which turns off the green light. So next we asked what would happen if we press the green light, because really it kind of is looking like, okay, well, rung 1 is winning. I mean, it certainly seems like it. Switch 1 on, green light comes on, switch 1 goes off, green light comes off. Let's just write a rule and say the first rung wins. But that's why this next one is so important to understand. So press and hold the green button, which is gonna make the green light come on. And let's walk through it and make sure we understand why. So this instruction is gonna say, go look for a 1. Where at input 8? Do I have one? No. So it's gonna be false. And it's gonna be false to our direct coil. And it's gonna say, go write a 0. Where to? Output 0. Now here's something that is very deceptive about the Connected Components Workbench software is when you're looking here, it sure looks like that this is true, but of course we have this break in the blue and the red. This right here means that the physical output is true. This over here means the instructions up to this point have been false. It's something that we're going to go, actually, I'm going to build another exercise out on this because I think this is worth spending a little more time on when it comes to machine troubleshooting. But let's continue down this path though. So this one went and wrote a 0 to output 0. So at that point, our global variable is off. Now it's going to go to the next rung. It's going to go look for a 1. Where? At input 4. Do I have one? Yes. So this is going to be true. It's going to go here. It's going to go back to the other side of the branch. And this is going to say, go look for a 1. Where? At the global variable associated with output 0, not this physical light. And at this moment in time, and there's where this is kind of deceptive, what you're seeing in the software, that is a 0. So this is false. But we do have a continuous path of true through the lower branch. So it's going to pass true on to our reverse contact, which is going to go and look for a 0. Where? At input 6. So it's going to continue with true to our direct coil. And a true direct coil is going to go write a 1. Where? To output 0. Now, this light, because this is something I hear a lot of people say, especially, come on, instructors, listen to me on this, because I hear this a lot coming out of schools, is people will tell me that this light is chattering really fast. Because every time this program scans, the first rung is turning off this light and the next rung is turning it on. But no, it isn't chattering the physical light. Now this global variable is getting a 0 and a 1 written to it every single scan. But this output does not update until the end of our program. So this green light is solid on. So then we're going to let off the button. And we're going to be at the exact same spot that we were the first time. So let's go through it again. Make sure we understand. This is going to go look for a 1. Where? At input 8. Do I have a 1? No. So this is going to be false. So it's going to pass false conditions to our direct coil, and it's going to go write a 0. Where to? To output 0. Then this instruction is going to go look for a 1. Where? At input 4. Do I have one? No. So it's going to be false. It's going to come to the next branch. And again, this split second timing difference, this instruction is going to go look for a 1. Where? At the global variable associated with output 0. So for this split microsecond in the program, this light is still on. But our global variable is false because rung 1 wrote a 0 to it. And it's going to make this instruction false. We don't have a continuous path of false that's through a branch. This is going to go look for a 0. Where? At input 6. It's going to be true, but we don't have that continuous path of trues from left to right. So it's going to pass false on, and our direct coil is going to go write a 0 to output 0. Then we're going to be to our end of program, and we're going to update our outputs, which is going to turn off the green light. Okay, so the final question was, what will happen if you switch 1 on and press the red button and the green light went out? But let's walk through it and make sure we understand why. So switch 1 is on. I have the red button pressed. So this instruction is going to go look for a 1. Where at input 8 do I have one? Yes. So this instruction is going to be true. It's going to pass true conditions on to our direct coil, and a true direct coil is going to go right a 1. Where to output 0. Then it's going to go to rung 2, and this instruction is going to look for a 1. Where at input 4 do I have one? No. So it is going to be false. It's going to go to the next branch. This instruction is going to go look for a 1. Where at output 0. Now we do have a 1 in output 0 despite this green light being off, because rung 1 just wrote a 1 to output 0. So this instruction is true. So we have true conditions through our branch to our reverse contact, and a reverse contact is going to go look for a 0. Where at input 6 do I have one? No, I have a 1. So that's going to be false. It's going to pass false conditions on, and a false direct coil is going to go right a 0. Where to output 0. Then we're going to get to the end of our program, and it's going to update its outputs and turn the green light off. Now again, especially for my instructors out there, this light is not chattering. In the PLC program, this is going from a 1 to a 0 on every scan, but since it doesn't update its outputs until the end of its program, it only matters what is in the global variable at the end. Now what I just said, all right, I'm gonna let off the button because my hand's getting tired. What I just said sure sounded like the last rung wins, because it only matters what is in the global variable at the end. But that does not mean the last rung wins. A PLC is going to evaluate each line of the program, and the entire program as a whole will determine the outcome of our PLC output. So after my RS500 version of this, I had a lot of people, 1, tell me this was just a gimmick, 2, that since the last rung usually wins, it was still a fair statement, and all types of other things. But this is one that if you truly understand how the PLC reads its inputs, scans and executes its program, and then updates its outputs, then you will be able to predict exactly what this program will do in each step. And it's not that the last rung wins, it's not that the first rung wins, it's that the PLC is going to win. It's going to be methodical and predictable every time. Till next time. Hi, this is Tim.
And this is Amber of TW Controls. We run the automation store. Hey, thanks for finding our channel.
Here's a playlist with some similar videos.
And YouTube thinks you'll like this video.
Please like our video and subscribe to our channel.
And if our videos have helped you make some money and you're not using our products, please consider supporting us on Patreon.
Till next time.
See ya!